Algebra II 6.1c, divide and simplify rational expressions, and I've got two theorems for you. If you haven't seen 6.1a or 6.1b, you might become confused, and there's links in this video's description so you can watch those very quickly before you watch this one. Two expressions are reciprocals of each other if their product equals 1. The reciprocal of a fraction, a divided by b, would be b divided by a. We just flip it around, don't we? Well, this is also true for rational expressions. If we've got x plus 2y divided by 3x squared y plus 7, we can just flip this around as its reciprocal, and when we multiply the numerator to the numerator and the denominator to the denominator, we're going to get a 1 because they'll be the same. It'll have the same numerator and denominator. If we have y minus 8, we can write it as a fraction, as a rational expression by putting it over a 1, and its reciprocal would be a 1 over y minus 8. And if we multiply the numerator and the denominator across, we'd get a 1. It would be y minus 8 over y minus 8, wouldn't it? Same numerator and denominator means it's a 1. Same thing with this one. We can flip it around to its reciprocal, and when we multiply it straight across, we're going to get a 1. Okay, so that's what we're going to be doing, and we're going to be eliminating those 1s in this video. So remember, 3x plus 2 can be written as a rational expression by putting it over a 1. Okay, then we can get its reciprocal by flipping it around, can't we? So here's our first theorem, reciprocals of rational expressions. For any rational expression, a divided by b, that's a non-zero. Okay, we can't have the b as a 0 because that would be undefined, wouldn't it? So for any rational expression, a divided by b, that is non-zero, its reciprocal is b divided by a. It's flipped around. So remember, we can always divide by multiplying by the reciprocal. This is also true for rational expressions. So whether you're dealing with fractions or rational expressions, which are basically the same thing, we can divide by multiplying by the reciprocal. Here's our second theorem, division of rational expressions. For any rational expression, a divided by b and c divided by d, as long as that c divided by d is a non-zero, okay? Then if we're doing a over b divided by c over d, we can flip this guy around as his reciprocal and then just multiply straight across, see? A times d and b times c. We can divide by multiplying by the reciprocal. So if we had 5/6 divided by 1/2, we could do 5/6 times 2 over 1. We just flip this guy around to his reciprocal, and we get 10 over 6. If we have 6x over 7 divided by 3, we can put him over a 1, couldn't we, to turn him into a rational expression or a fraction? Then his reciprocal is going to be 1/3. Then we can just multiply straight across. We get 6x over 21, see? All right, so let's see if we can eliminate some of these guys as 1s. We've got x minus 2 divided by x plus 1 as our first rational expression. Then we've got this one. We've got x plus 5 over x minus 3. And they want us to divide it. So what we're going to do is flip this guy around. So the orange is on the bottom and the green's on the top. And we're just going to multiply straight across. Numerator to numerator, denominator to denominator. And we look for any identical numerator and denominator parentheses values, and we don't see any. So there's no 1s to eliminate in this one. So that's our answer right here. That's as simple as we can go. All right? So let's take a look at this one. Now, we've got a squared minus 1 over a plus 1, and they want us to divide it by a squared minus 2a plus 1. That looks like it could be factored, doesn't it? And that's over a plus 1. So what we do is we flip it around and put the orange on the bottom and the green on the top, and that's multiplying by the reciprocal. See, we changed it to a multiplication sign. Now, we just factor the numerator. This a squared minus 1 becomes a plus 1, a minus 1 when it's factored. It's going to be over an a plus 1. And look, we have two a plus 1s right here that make a 1, don't we? And for this one, when this denominator is factored, we get a minus 1, a minus 1. And this a minus 1 can be put over this a minus 1 when we regroup them like this. So that means we have a 1 here and a 1 here, and 1 times 1 is 1, times this is just going to be that, isn't it? It's going to keep its identity as identity property, all right? So we were able to eliminate this and end up with just that guy, all right? Let's try another one. We got 6x plus 12 over x. They want us to divide it by x plus 2 over x to the third power. We're going to switch this guy around so the green's on top and the orange is on the bottom, like that. Now we're just going to multiply by the reciprocal. When we factor this, we get 6x plus 2 with the x plus 2 in parentheses, and that's going to be over the x. See, if we did distributive property, we'd go back to 6x plus 12. See, it's factored. And then this guy is going to be x to the third power over x plus 2. And look, we have an x plus 2 and an x plus 2. We can regroup and rewrite this so that the x plus 2's are over each other with one long bar. See, one long rational expression or fraction bar. And remember that we subtract exponents because of the quotient rule. So if we have an x here and 6x to the third here, we're just going to have 6x to the second. See? It's going to take one of them away. We subtract from the quotient rule. And these two become a 1, so we can eliminate it because we're just saying this times 1. And we don't need to write that 1, do we? So what we did was we multiplied by the reciprocal. We factored the numerator and denominator and regrouped it so that we could see where the 1's were, and then we removed all those 1's to simplify. Okay? So just remember, rational expressions are just fractions. We're going to just treat them just like fractions. Okay? And just remember your rules for exponents. Okay? So our next video is 6.2a, and we're going to add rational expressions with like denominators. I'm going to add this video to the Algebra II playlist. I'm going to put links to the previous videos from Algebra I that discussed this topic. There's 4 of those. And any previous videos from this chapter, from this playlist, will be in the description so you could just click on them. All right? And maybe I'll even put a thing in there about the quotient rule if you forgot. Okay? All right. So I'll see you next video. Keep trying. I'm proud of you. We can do this together. Just make sure you watch each video so you don't get lost, okay? All right, bye.